And now we're going to measure the turbidity of the 5 Green River sample spots. In order to measure the turbidity, we're going to use a turbidity sensor. It even says so right there, turbidity sensor. And we talked about this in pre-lab a little bit, but the basic way that a turbidity sensor works is we're measuring the amount of cloudiness. And so for instance, if we look at sample spot 5 and what that actually looks like compared to something like sample spot 3, so we're quantifying how much cloudier this is than what this one is. And in order to measure turbidity, we use something called nephelometric turbidity units, or NTUs. And so really what we're looking at is how much of the light is able to pass through the sample, and look at quantifying that. And so the first thing we have to do when we're using some sort of sensor like this is we need to calibrate it. We need to use a couple of different known samples of NTUs and use that in order to help the instrument establish the relationship between the amount of light that passes through and what the actual NTU value is. Now, just to give you an idea of the setup here, so again, we have the turbidity sensor, which we'll be putting the samples in, and we'll talk about that in just a minute. We're going to put our samples into the turbidity sensor, and after we have it calibrated, it's then going to give us our turbidity right on our screen in our software. Now, I just want to show that to you so you get an idea of what I'm looking at as I read the data here. So this is what it looks like. And you can see down here in the lower left corner here, this is where I will actually be recording the turbidity from. So once I have everything calibrated and I start reading off the results and I post the results later in the spreadsheet, that's what it looks like. And so I'll be calibrating the meter and then simply taking my measurements right from the software. All right, let me just get this set up a little bit better here. Okay. And so first thing that we have to do, like I said, is to calibrate the instrument. Now, when you're recording in your notebook, you don't necessarily need to record all the steps that I go through here for calibration and everything that I do. I've done this enough so that I know what I'm doing when I calibrate. If you were in here in the lab actually doing it, you would use the calibration instructions that we always provide to students. What you would need to record in your notebooks as you are doing this though. And so one of the ideas of your notebooks, or when you're thinking about the audience that you're writing your notebooks for, you want to be writing enough detail in your lab notebooks that if this happened, you could simply pass your notebook to another 114 student and they would be able to come right into the lab and conduct the experiment using your notebook. And so you need to write in enough detail that another 114 student could do the same thing that you did. And so I'm about to go through a number of different steps here in order to calibrate the turbidity sensor. What you would need to write in your notebooks, or if you were doing this, again, you wouldn't write down every step, but you would say something to the effect of the turbidity sensor was calibrated using 0 and 100 NTU standards. And with that information, another 114 student could duplicate that portion of the experiment if they wanted to. And so that's the level of detail that you need to be thinking of in your notebooks. And so I'm going to go ahead and go through that now. I'm going to calibrate the turbidity sensor. And I'll show you just some of the things that I do as I am doing this. So the first thing I'm going to put in here is the 100 NTU standard. Now I do need to make sure that this is actually nice and homogeneous throughout the mixture. And so what I want to do is just mix it up a little bit. You'll notice that I'm not shaking it, I'm not vigorously shaking or anything like that. I'm simply inverting this a few times to make sure that it is nicely mixed. Now, since we are measuring the intensity of light that passes through, I don't want there to be any smudges or anything on this glassware that could interfere with that light. And so I use Kim wipes. That's what these little wipes are. If you ever see these in a lab station, they are not paper towels, they're not used for cleaning, or they're not used for cleaning up spills. They are used for wiping down and cleaning up glassware for exactly this sort of purpose. And so before I put any of the cuvettes into the turbidity sensor, I'm going to wipe them with the Kim wipes. And then I will make sure to always hold it by the top so I don't smudge anything on that glassware. The other thing I need to keep in mind when I'm inserting these cuvettes into the meter is I always want to make sure that the orientation is going in the same way each time. Imperfections in the glass could lead to different light intensities passing through. So the way that we correct for that is just to simply make sure that we're always putting this in there the same exact way each time. And so yes, there might be imperfections that are interfering with the pathway of light, but if I put this in there the same way every time, then those imperfections impact the data the same way every time. And so it's not going to be a factor in the difference in numbers. And so you can see the arrow that's on the cuvette. I'm going to line that up with the arrow that is inside the meter. So I'm going to do that every time that I put a sample into the turbidity sensor. So I've got my 100 NTU standard in there. I close the lid. I type, oops, I need to calibrate now, 100. And I'm just, again, going through our calibration instructions. Next, I'm going to just use some distilled water. So I'm just going to fill one of our cuvettes up to the line with some distilled water. Wipe this down. And now my instrument is calibrated. It's always a good idea after you calibrate an instrument like this, just to make sure that it is reading accurately. And so right now my 0 turbidity standard is in there. I'm just going to pop the 100 back in. And I see that it is reading 100.6 NTUs. Perfect. I mean, no, it's not dead on 100, but turbidity's one of those things, since we're looking at cloudiness, we do expect a bit of fluctuation in our data. And so 100.6, it's actually now reading 100.2. It's pretty much spot on. If I put the 100 back in there and it was reading 64, or it was reading 172, then there's a problem with my calibration. I'd want to go back and recalibrate and try to fix that. But I can see that it is reading pretty accurately. My water should be reading pretty much at 0, so let's check that. Sure enough, 0.2. So that's pretty darn close. And so my instrument is now calibrated and ready to use. And so now we're just going to start to get the readings for our Green River sample spots. I'm going to dump the water out of my cuvette. Sample spot 1. I'm just going to invert it a couple times, make sure it's nicely mixed in there. Add some sample spot 1 to the cuvette. Now again, when you're writing in your notebooks, you don't need to go into that sort of detail. I'm just explaining what I do as I do it. But you certainly don't need to write down added sample spot 1 to the cuvette. That's a level of detail that is unnecessary. Again, you want to be keeping in mind that you want to write down something that would enable another 114 student to repeat this. Now I'm wiping this down and getting it ready. So my initial reading for sample spot 1, 9.6 NTUs. Now, as discussed in pre-lab, we always want to take replicate measurements whenever we can. We never just take one measurement and call it good. We want to make sure that our data is reproducible and that we can get good, precise data sets. The way we are going to do that with our turbidity meter, our turbidity sensor, is I'm literally now just going to take the sample out. I'm going to put it back in, and I'm going to get another reading. Now I get a reading of 8.3 NTUs. Out and back in. .6 NTUs. Now again, this will all be in the spreadsheet. You don't need to necessarily record as I am speaking, but you can if you want, but it will all be provided in the spreadsheet for you. And so I'm going to do that same thing for sample spots 2, 3, 4, and 5. I'm going to be getting triplicate measurements of each. As part of your post-lab analysis, what you are going to do is find the average of those, so the average of those 3, that will provide your turbidity reading for sample spot 1. You're then, in order to analyze the precision of this data, you're then going to find the standard deviation and the percent standard deviation, the percent RSD, for that set of triplicate measurements. That will then start to give you an idea for how precise this data set is. And again, this was discussed in pre-lab, but if you're getting percent RSDs of 6%, 10%, 12%, I mean, somewhere like that, that's a good, fairly precise data set. We start getting percent RSDs 30, 50, 100%, something like that. That's when we need to start thinking about how well we can actually trust our data, how much we can trust our data. And so that's why we're taking triplicate measurements. So you're then able to think about the reproducibility of your data, to think about how precise is my data set. And so let's keep going. So dump out sample spot 2, or sorry, dump out sample spot 1. Add in sample spot 2. Actually, sorry, I need to just check something off camera just one moment. I'll be right back. Okay. Sorry, right back. Okay. And so now on to sample spot 2. Sample spot 2, I get a turbidity of 77.2. For our triplicate measurements. Second reading, 76.8. For our third reading, 77.7. Sample spot 3. 41.2. .4 and 40.1. Sample spot 4. Just as a visual observation, I should have shown you the others as well, but a visual observation, sample spot 4 is much cloudier than sample spots 1, 2, and 3 were. Sample spots 1, 2, and 3 visually didn't look that cloudy. Sample spot 4 definitely looks quite cloudy. And so sample spot 4, my initial measurement is 513 NTUs. Now that's a problem. As discussed in pre-lab, hopefully, if I remembered to, calibrations or instruments like this, the measurements are only valid within our calibration zone. In other words, our calibration standards were 0 NTUs and 100 NTUs. That means that any measurements that we take are only valid within that range. Outside of that range, we don't know if the same relationship necessarily holds true, so we cannot simply trust those measurements. So what I need to do now that I have a measurement that is so far outside of my calibration range, is I need to dilute sample spot 4 down to a point where it is now going to be within our calibration range. And so we're at 500 NTUs. I need to get it down somewhere between 0 and 100. I'm going to do a 1 to 10 dilution. I'm going to do a 10-fold dilution of sample spot 4. There's a couple different ways to go about that. I mean, essentially, I'm going to take something and dilute it by a factor of 10. So I could, for instance, take a 10 mil graduated cylinder, add 1 milliliter, and then dilute that up to 10 milliliters, and that would give me a 10-fold dilution, and then I could measure that. A couple problems with that. One is that 10 milliliters I don't think will be enough for our cuvette. Also, measuring 1 milliliter, not real accurate. It's tough to measure that small amount accurately. So what I'm actually going to do is I'm going to use a 100 milliliter graduated cylinder. I'm going to add 10 milliliters of the actual sample, and then I'm going to dilute that up to 100. That will be a 10-fold dilution. I will then use part of that sample in order to conduct my measurements. I'm just rinsing out my cuvette first while I'm thinking of it. And so now I'm going to add 10 milliliters of sample spot 4 into the graduated cylinder. That's close. I'm just going to use a pipette to get it the rest of the way so that I don't overshoot. A little bit more. There. So I now have 10 milliliters of sample 4 in my cylinder. I'm just going to go off camera now and fill this up close to 100. So now we're close to 100. I'm just going to use my squirt bottle and get me up to the top. There. I now have some of sample spot 4, which has undergone a 10-fold dilution. And so now we can take our measurements of sample spot 4. I get an initial measurement now. So I'm actually on my notebook, 10-fold dilution. I get 33.3 NTUs. $32.6 NTUs. And 34.1 NTUs. Now, so keep in mind that what you're going to be doing for your analysis is finding the average of those 3 measurements, and that will be your turbidity value for sample spot 4. And so that's going to be roughly, again, you're going to find the actual average, but that's going to be roughly 33 or so, 33.2, 33.4, something like that. Keep in mind, though, that when you find that, that represents a 10-fold dilution of the actual sample. So whatever number you find for sample spot 4, when you take this average, you have to then multiply that by 10. That will get you back to what it really was sitting in the flask. Now, and this also shows you that why it's necessary to do this. Before we diluted, we were getting NTU values or turbidity values up around 500 for this sample. The actual value, when we diluted and got to within our calibration range, was more like around 330 or so. So this shows us that absolutely, this meter is not accurate outside of that calibration zone. And so that's why this illustrates perfectly to us why it's necessary to do what we just did. And so now, last but not least, we'll move on to sample 5. Sample spot 5, 422 NTUs. So I have the same issue. I need to do a 1 to 10 dilution of this to hopefully get me down to within my calibration zone so that I will have measurements that are reliable. So let's just rinse out our graduated cylinder here that we just used. And I'm just going to do the same exact thing that I did for sample 4. Add 10 milliliters here of sample 5. Perfect, dead on. Now again, I'm just going to go off camera here and dilute this to 100 milliliters. There's our 1 to 10 dilution of sample spot 5. Add that to our cuvette. And we get a measurement of 27.6 MTUs. $28.9. And 28.2. And so that concludes all of our data for the turbidity portion of Module 1. So all that data will be available to you on the experimental data spreadsheets. And so you can conduct all of your post-lab analysis using that. Thanks for watching. And my remote still isn't working, so you get to see me come in close and personal to turn this off.